Dinosaurs did not take over Earth in a single triumphant leap. For tens of millions of years, they were only one part of a crowded Triassic world packed with other reptiles, other predators, and other herbivores. Then the balance changed. Food webs shifted, rivals disappeared. Dinosaurs spread into roles that had belonged to other animals. By the Jurassic, the land was theirs. By the late Cretaceous, they had ruled for roughly 180 million years. And then they lost everything. That is the real question behind dinosaur success. Not why they were impressive. That part is obvious. The question is how they conquered the world at all, and why a dynasty that durable still ended in a geological instant. There used to be two neat stories. One said dinosaurs simply outcompeted everybody else. The other said extinction events cleared the board for them. The current evidence is less tidy and more interesting. Dinosaurs seem to have risen through a long interaction between adaptation and opportunity. They were helped by crises. They also knew what to do with the openings those crises created. To understand dinosaur success, you have to start before dinosaurs mattered. The end Permian mass extinction, about 251.9 million years ago, was the worst biological crisis in the history of animal life. Marine ecosystems collapsed. Land ecosystems were ripped apart. Recovery was slow, unstable, and uneven. That broken world mattered because the Triassic was not a settled paradise waiting for one perfect group to arrive. It was an experiment under stress. Pangaea still existed as a giant supercontinent. Much of the interior was hot and seasonal. Ecosystems reorganized repeatedly. Archosaurs diversified into many forms. The crocodile line branch, the pseudotsuchians, produced armored herbivores, giant predators, and strange semi-aquatic forms. Theropsids and other older lineages were still present too. Dinosaurs emerged into that traffic, not above it. The earliest unambiguous dinosaur fossils are at least about 230 million years old in the late Triassic. But that date can mislead people. The first dinosaurs were not immediately the top animals in every ecosystem. According to Martin Quarnström and colleagues in Nature in 2024, terrestrial ecosystems clearly dominated by dinosaurs across multiple trophic levels do not appear until the early Jurassic, roughly 30 million years later. That delay matters. It tells us dinosaur supremacy was built, not granted. In many late Triassic communities, early dinosaurs were still relatively small and ecologically limited. Pseudotsuchians remained major players. So did phytosaurs, adasaurs, dicynodont holdovers in some regions, and a broad array of other reptilian forms. Some early dinosaur relatives and precursors persisted alongside true dinosaurs for long stretches. Even in places where theropods had appeared, they were not yet the only serious predators in town. If dinosaurs were destined to rule because of one overwhelming advantage, they took a surprisingly long time to show it. One of the most useful newer studies on this question did not start with dinosaur skeletons. It started with fossilized digestive remains. Quarnström's team analyzed more than 500 bromelites, fossil feces, gut contents, and regurgitated material from Triassic-Jurassic assemblages in the Polish Basin. That evidence let them track not only what animals existed, but how food webs were being reorganized. Their conclusion was not a clean, single-cause victory story. It was stepwise. First came opportunistic and omnivorous dinosaur precursors, occupying some roles left unstable by earlier ecosystem stress. Then came insect-eating and fish-eating theropods, plus small omnivorous dinosaurs. Later, climate-linked vegetation changes widened herbivore opportunities, and large sauropodomorphs, and early ornithischians expanded into them. After that, theropods scaled up in response to the appearance of these new herbivore guilds. In plain terms, dinosaur success appears to have built upward through the food web. They did not start as instant giants. They entered vulnerable systems, widened their diets, expanded their body sizes, and increasingly occupied ecological roles that were either newly available or newly profitable. That matters because it changes what conquered the world actually means. It was not one decisive battle. It was a long occupation of ecostase. The real acceleration came near the end of the Triassic, around 201 million years ago. This was another major extinction interval, closely tied to Central Atlantic magmatic province volcanism as Pangaea began to rift apart. Huge volcanic outpourings altered atmospheric chemistry and climate. Marine systems show signs of severe stress. A 2023 Nature Geoscience study by Andrew Bond and colleagues adds to that picture by documenting severe shallow shelf euxinia during the end Triassic extinction. On land, the details differ by place and lineage, but the broad effect is clear. Many non-dinosaur competitors that had shared or dominated major ecological roles vanished or were sharply reduced. Dinosaur-bearing ecosystems then expanded through the Jurassic. That does not mean dinosaurs passively inherited an empty world. The story is sharper than that. They inherited a world where certain rivals had been removed, and they were well positioned to exploit what remained. Payne and colleagues studying the long-term history of crocodile line archosaurs show that these lineages were shaped by both abiotic and biotic pressures across deep time. Their work also underlines that competition with dinosaurs is at least a plausible part of the later picture for some Pseudosuchian groups. The old debate between they were better and they got lucky breaks down here. Dinosaurs seem to have been good enough to capitalize on luck. By the early Jurassic, the basic architecture of dinosaur rule was in place. Sauropodomorphs were expanding into large-bodied herbivory. Theropods were diversifying as active predators. Ornithischians, though initially modest, were establishing the other great herbivorous branch that would later produce armored dinosaurs, horned dinosaurs, and duck-billed forms. Dinosaurs were no longer local experiments. They were now structuring the land vertebrate world. And this structure lasted. Through the Jurassic and Cretaceous, dinosaur evolution kept generating size, range, and trophic breadth on a scale few land vertebrate groups had ever managed. Sauropods reached body sizes that transformed plant consumption and landscape use. Theropods ranged from small feathered hunters to giant apex predators. Ornithischians diversified into a wide spectrum of feeding strategies, armor systems, and headgear. Dinosaurs spread across continents, climates, and habitats. This was not static rule. It was a long, adaptive regime. People often imagine dinosaur dominance as nothing more than giant predators and giant herbivores. The real achievement was ecological coverage. Dinosaurs held top predator roles. They held major large herbivore roles. They occupied medium-sized and small-bodied niches too, especially once birds and bird-like forms are included within Dinosauria, as they must be. Their trackways, nesting sites, bone beds, growth series, and biome-scale distributions show a clade that was not merely surviving environmental change, it was repeatedly reorganizing around it. That durability is why their fall feels so dramatic. If dinosaurs had only lasted a short interval, Chicxulub would still be famous, but it would not carry the same weight. What the asteroid ended was not a brief experiment. It was one of the longest and most successful terrestrial dynasties in the history of complex life. This is where the second half of the title begins. If dinosaurs lost it all, had the loss already begun before the asteroid? That remains debated. Some analyses have argued for declining diversity in at least some groups during the latest Cretaceous. Others argue the apparent decline is exaggerated by fossil record bias. In 2025, Christopher Dean and colleagues in Current Biology, summarized by UCL, argued that the North American record may make dinosaurs look as if they were fading because the youngest rocks are less exposed and less accessible. In their view, at least part of the decline signal may be a sampling problem rather than a biological collapse. That is an important correction. It means we should be careful with any script that frames the dinosaurs as doomed and stumbling before Chicxulub arrived. The cleaner current position is that the picture was regionally complex and unresolved in detail. Some clades may have been under pressure. A global, universal collapse before the impact is not established. And in one key sense, the exact answer does not change the main story. A dynasty can be stressed and still alive. Chicxulub did not need the dinosaurs to be thriving perfectly. It only needed them to be vulnerable to abrupt loss of sunlight and food. The mechanism of the fall is far less uncertain than the exact shape of the final pre-impact curve. The Chicxulub asteroid struck 66 million years ago and triggered the Cretaceous-Paleogene mass extinction. Alfio Chiaranza and colleagues argued in PNAS in 2020 that the impact winter scenario, not Deccan volcanism on its own, is what destroys dinosaur habitability in their models. The atmospheric shock from impact, including dust, soot, and aerosols, suppresses light and triggers a collapse in global food supply. Long-term volcanic warming, by contrast, does not produce the same extinction state for non-avian dinosaur habitats. That fits the broader physical picture. Large terrestrial dinosaurs depended on land food webs with huge throughput. Herbivores needed plants. Large carnivores needed functioning herbivore populations. Once sunlight crashed and primary productivity collapsed, the biggest winners of the Mesozoic became some of the worst-positioned survivors. Their strengths had all been built for a world that still had plants, seasons, and functioning ecosystems. Chicxulub attacked the base of the system itself. The strangest part of the dinosaur fall is not what died, it is what did not. Birds survived because birds are dinosaurs. Some crocodilians survived, turtles survived, mammals survived. The filter was not prestige or size, it was ecological fit to a ruined world. Smaller bodies, freshwater refuges, generalist diets, seeds, sheltering behavior, and lower food demands all mattered. That survival pattern also tells you what dinosaur supremacy had become by the end. It had become a system dominated by large-bodied terrestrial success. That works brilliantly for millions of years. It works very badly when the sky closes and the food web snaps. So how did dinosaurs conquer the world and lose it all? They conquered it because they entered unstable ecosystems, persisted through a long apprenticeship in the Triassic, expanded step by step into new diets and body plans, and then benefited from extinction-driven openings that erased many of their rivals. Their success was not pure luck. It was not pure superiority either. It was a long interaction between environmental upheaval and a clade ready to exploit it. They lost it because the final catastrophe worked on a different level from the pressures they had mastered before. Dinosaurs had survived competition, climate shifts, continental change, and ecological turnover. Chicxulub did not challenge them to adapt gradually. It shut down the light and broke the food web under their feet. That is why the dinosaur story still matters. It is not just a story about giant reptiles. It is a story about how dominance is built over millions of years, and how even the strongest dynasties remain hostage to the stability of the world that feeds them. If you want more long-form prehistoric documentaries built from the actual science, subscribe. And if you want the next chapter in this rise story, the full history of the Cretaceous is the natural place to continue.